Hey, in this video, I'm going to show you how to solve the ALEKS problem called using the Faraday constant. In this problem, or to solve this problem, you're going to be using the equation A equals C over S. And in this equation, A stands for amps, and it represents the current. Amps are a unit of current. Which is kind of a bummer because this equation has a C in it, but the C in this equation does not stand for current. It stands for Coulomb, which is also a unit, and then that S, I'm just going to rewrite this. This is a unit of seconds. So there are three different versions of this ALEKS problem. Each version is asking you to solve for one of these three variables. So for example, if the problem is asking you to solve for current or asking you to solve for amps, this is the version of the equation that you would be using. If the problem is asking you to solve for coulombs, then you would just rearrange this equation so that it would be amps or current times a second. This is the equation that you would use. And then if the problem is asking you to solve for time, you would use coulombs divided by current or coulombs divided by amp. So your first job in this problem is to figure out which one of these three equations that you need to use. And of course, that's going to depend on the problem itself. So if I'm looking at this problem, I can see that ALEKS is asking me to solve for how many moles of electrons. Now, that seems like kind of a bummer at first because we have three equations and none of them involve moles at all. We have an equation for amps, we have one for current, we have one for seconds, but we don't have an equation for moles. That's where Faraday's constant comes in. Faraday's constant is 96,485 coulombs per mole, and it is the conversion factor that allows us to go back and forth between coulombs and moles. So you best believe in this problem that you are going to have to do one of these coulomb to mole conversions. Either the problem is going to provide you with moles and you're going to need to convert it into coulombs to plug it into one of these equations right here, or in my case, the problem is asking you to calculate the number of moles, and you're going to do that by first solving for coulombs and then converting from coulombs into moles. So depending on what the problem is asking you to do, you might be using Faraday's constant in this form with coulombs on top and moles on the bottom, or you might be using it flip-flopped with the moles on the top and the coulombs on the bottom. Okay, so let's take a look at my problem is asking me to solve for the number of moles, and that if I have to solve for the number of moles, I first need to solve for coulombs, and then once I know the coulombs, I can convert into moles. And like I said, in the other versions of this problem, you are going to be given moles, and then you'll have to convert moles into coulombs so that you can plug it into this equation right here, or plug it into this equation right here. So I am being asked to solve for coulombs, essentially, and that is going to be my amps times seconds. The problem tells me that I have 840 milliamps. I need to convert that into just regular amps. 840 milliamps divided by 1,000 is going to be 0.840 amps. And then my time in units of seconds, you got to watch out. I did see some ALEKS problems that were using different time units like minutes and things like that. So you might have to do like a minute to second conversion. And when I multiply these together, the unit that I'm going to get is coulombs. Amps times seconds is coulombs. 283 times 0.840 is 237.72 coulombs. And again, this problem is asking me to solve for moles, not solve for coulombs. So that's where I'm going to use my Faraday's constant to convert from coulombs into moles. Now, because I'm already in the coulomb unit, I want a conversion factor that has coulombs on the bottom so that unit cancels, and I want moles on top. That means that I'm going to be using this form of Faraday's constant right here, 1 mole over 96,485. And I messed that up, 96,485. That gives me an answer of 0.002, I want 3 sig figs, 246, and my unit is moles because those coulombs canceled out. This is one of those problems where ALEKS is asking you to write the unit symbol down. So make sure you include that and that. So just so that you have kind of like a complete set of examples of how you would do this, I'm going to do another version of this problem, that would involve using one of these other equations right here, just so that you get some practice. So the next version of the problem that I'm looking at, I'm just going to go ahead and erase this. I'm looking at on my computer right now, it says that we have 230 millimoles, and it says 203 seconds. And it wants to know what the current is. It says calculate the size of the current that must flow. So since I'm being asked to solve for current, which is A, this is the form of the equation that I want to use. My current is going to be the coulombs divided by time in seconds. To get coulombs, I'm going to get coulombs from the moles using Faraday's constant as a conversion factor. I'm just going to do that math down here. 0.230 moles, 230 millimoles divided by 1,000. This time I want mole unit on the bottom and coulombs on the top. And that means that I'm going to be using this version of Faraday's constant, 96485 coulombs per mole, so that my mole units cancel. And that is 0.230 times 96485. 22,192 coulombs. And I'm just going to plug that in here, 22,192 coulombs. My time was 203 seconds. And 203, that is 109. The unit is amps.